Welcome to the video tutorial of Eulers equation. In this tutorial, we shall see how to plot Eulers equation in 2D and 3D. We are essentially doing this because of two reasons. One is we actually find it very interesting to plot it in 3D. And two, it gives us an intuitive understanding, a better understanding of Fourier series. And we shall see that in next lecture. So we start from what we know, that's the complex numbers we have studied in our elementary standard. And we know that how to plot a complex number z is equal to a plus ib, and the process will be similar in the case of e power I theta equals cos theta plus I sin theta also. And this is the famous equation given by the Euler, and it is termed as Euler's theorem. If we plug some values, a random value to the theta in e power I theta, we will get a complex number. And this complex number can be similarly plotted in 2D as shown. So let us apply the same to see the complete picture how e power I theta will be in 2D. For this, what we do is we vary values for theta from 0 to 2 pi. We can also vary theta greater than 2 pi, but it is not that convenient. We shall see that. And also we know that the magnitude of e power I theta is equal to 1. By summing up all these things and varying theta from 0 to 2 pi, we expect it to be a circle of radius 1 unit. So this is how it will look in 2D. And what if we vary theta greater than 2 pi? We can do that. But how does it look like? Since this is a periodic structure, the same pattern repeats and you can't identify the change. This is because we have not given any freedom to theta. So now let us give some freedom to theta and show up itself in another dimension. Here we are getting into 3D by adding the dimension to theta. We are putting theta on the z-axis, so this results in a 3D waveform. Right? 3D will always be awesome, right? So this will be cool. Let's see how this will look like. How e power I theta will look like in 3D. Let us take a right-handed system, coordinate system, in which x is real part and y is imaginary part, and theta will be in the z direction. And as we have seen, the theta, for various values of theta, you can expect this kind of structure. It comes out to be a spiral. What all you need to do is you need to apply the basic understanding of how to plot a complex number. The additional thing that we have added is theta. So let us take some values to theta. For theta is equal to 0, we get a real number 1. For theta is equal to pi by 2, it gives us a complex number which shall not be on real part or on the imaginary part, it will be somewhere else. And for theta is equal to pi by 2, it comes out to be purely imaginary. If you keep doing this and try to combine all the points of the sticks, we eventually end up with a spiral. It's spiral, it just looks like a spring. Then can we see the classic sine and cosine wave in this spiral? If that is your wish, it is going to be fulfilled in few more moments. Let's see how to arrive at the sine and the classical sine and cosine waves from this spiral we have seen. We know that x, the real part, is cos theta and y is the imaginary part, the sine theta. So to see cos theta alone, we have to look into the plane and see the spiral's projection onto the x theta plane. And we do this by neglecting the y plane, by y axis. So let's see how does this come out. And I'm doing the same process that I have done earlier to plot the spiral. Here I'm trying to indicate the sticks that are above the x theta plane with a blue tip and the sticks that are below the x theta plane with a red tip. And what all we need to do is we need to project these sticks onto the x theta plane. If you do that, we will end up with something like this. And if you join all those projections, what you see is a cos theta, the classical cos theta waveform. And in a similar fashion, if you do want to see sine theta, we need to project the spiral onto the y theta plane by neglecting the x-axis, and this can be shown like this. You take y theta, you take the y plane, y-axis, and theta axis, and you need to project all the points onto the y theta plane, and after projecting you need to join all those points. Once you join, we need to see what kind of shape it will come up to. Here I'm randomly taking the values to be 0, the values for theta to be 0, pi by 4 and pi by 2, which will be easy to plot. You can see that projections, right, onto the y theta plane, and it is coming out to be a known shape that is the sine wave. And this is how we plot the sine wave from the spiral. It's all just projections. To completely nail down the concept, let's see this animation. You can see various values for theta, and this is how it looks like. The spiral from the top view looks like a circle, and it is the 2 dimension. This is how it looks like. I hope this video gives you an insight into the e power I theta, and this will obviously help you in understanding the pictorial representations of Fourier series, which will be my next video. Thanks for watching.